Hello and good evening, CSI135 Section 400 students for the Fall 2013 semester at Anne Arundel Community College. Tonight's video tutorial is going to be the solution set for quiz number 1. And so the quiz was emailed out at the start of class on Wednesday evening, and if you issue the mail command followed by the enter key, you're going to see a list of email messages, and you can see that you had quiz number 2. So I would select message number 2. And we're going to go ahead and work our way through here. So it's hello and welcome to quiz number 1, message number 2. Okay, so question number 1. The output below was generated using the ls command and 4 options. What were the 4 options? So from taking a look and from our lecture in class, you can clearly see that the inode number is listed in the far left-hand column. So -I would be one of those options. You can also clearly see that the permissions are shown for each of the files. So the -L option, which would show a long listing, was used. If you look over to the right, you can see we have some hidden files that have been shown. So the -A option would be used. And then the final option required you to take a look at all of the files and all of the information for the files and to recognize that the files are being listed in chronological order from newest to oldest. And so the option that would be used there would be -T. So if I do a man on ls and I come down to -T, you can see that -T is sort by modification time. So let's do ls-lait in my home directory, and let's see if that works. It certainly does. You can see we got a chronological listing of when things have been modified. It shows the hidden files. It shows the permissions for the files, as well as the inode number. So again, the correct answer for number 1 is LAIT. Those were the options that were used. All right, on to number 2. It says the following output should be used to answer the following questions. And there were 4 sub-questions here, A through D. And we're looking at output from the mail utility here. So as you can see, I've received a number of email messages, and we're focused on this column here, the first column on the far left. So it says, which message is the current message and how do you know? So as we discussed, the current message is indicated by the greater than sign. So the current message would be number 5, and the reason that we know is because the greater than sign is indicating that this is our current message. Which message numbers have been saved as files? You'll remember from our lecture on the mail utility that the asterisk is placed next to any messages that have been saved as files. And so these will not be saved to your inbox file when you quit. So messages 2 and 6 have been saved as files. If you were to issue the Q command at the ampersand, how many messages would be saved to your inbox file? So remember, messages that have been read and not deleted will be saved off to your inbox file. Save messages and messages with the N, which indicates a new message, will not. So it would be message number 4, message number 5, and message number 8. So 4, 5, and 8, so a total of 3 messages will be saved to your inbox file. If you were to issue the Q command at the ampersand, which message numbers would remain in the var spool mail CSI135B, and the XX simply indicates your login ID number. So if I'm B25, it would be B25. If you're B5, it would be B5. And again, the messages that are going to be left in the mail file will be the messages that are new. So 1, 3, 7, and 9. So a total of 4 messages. And those were your answers for number 2. Number 3, provide the commands using a pipeline that you could use to produce the following output from the parent directory of your home directory. So again, if I type pwd, you can see that I'm in my home directory. I can also tell I'm in my home directory because of the tilde inside my prompt. If you're not certain, you can type cd by itself, and let's say you're in user bin for whatever reason, and you want to get to your home directory, again, it's simply the cd command, which is a shell built-in, and you would hit enter, and then there's your tilde. So it says provide the commands using a pipeline that you could use to produce the following output from the parent directory of your home directory. So let's go up one directory. Now we're in the parent directory, which is CSI135. If I type ls to see a full listing of everything that's in here, as you can see, it's all sections of the CSI135 course, A through F, and all of the student home directories. So if I were to type ls and simply grep on B, I would get a list of all the B directories. But if we take a look up here, you can see that this is listed in an interesting fashion. In fact, it's reverse sorted. So I could type ls and I could pipe it to sort dash R. And let's see, does that, oh, I'm sorry, apologize. We'll type it to ls and we'll grep on B, and then we'll pipe it to sort dash R. All right, does that get us the answer? Whoops, it certainly does. B9, B8, B7, B6, 5, all the way down to B10 and B1. So your correct answer for number 3 is ls, which is piped to grep for the letter B, which is piped to sort minus R to reverse sort the output. So that's the correct answer. All right, question number 4. There is a file located in the following directory, and so let's go ahead and move to this directory. I'll copy and paste this to save us some time. Whoops. Let's paste that. There we go. So I'll type ls, and there's 100,000 colors for you. So let's take a look at the particulars on this file. As you can see, the file is extremely large. It's over 1 million bytes in size. So if I were to cat this file, you can see it's going to list out quite a few colors. We've got lots of colors in there. So your task is to use the Linux utilities that we've discussed so far to produce a list of the colors that are listed in the file. 10,000 colors for you. You only need to list the name of each color one time in your answer. So what we need to do is we can simply right out of the gate type sort 10,000 colors for you, and we'll pipe it to more and we'll see what that looks like to make sure we're getting it. Yep, there's blue, and blue appears quite a bit in the file. Holding the space bar down right now to work my way through. And the file is very, very large, as you can see. So I'm going to quit right there. So if we sort it and pipe it to unique, this will remove all duplicate adjacent lines. So you could simply do sort 10,000 colors for you and then pipe it to unique, and here is a list of your colors. Another way you could do it would be to cat the file, pipe it to sort, and then pipe it to unique. And again, you'd be using an additional command which would create a little bit of overhead, but nothing that can't be overcome by the system. And again, you get a list of your 5 colors: blue, green, red, teal, and yellow. So that was the answer for number 4. Number 5. Let's take a look here. I pasted some information in there accidentally. Alright, so number 5 is asking you, says there is a file located in the following directory. Your task is to provide the phone number for the individual, and I'm going to copy that, is to locate the phone number for the individual who is in this file. So here's our file, and it's bzipped. So in order to get that file into a format that we can read, we can use bzcat, and bzcat will cat the file out. And then I'm simply going to do the grep utility, and I'm going to grep on Geek Squad, or just simply Geek. Alright, and Johnny Geek Squad's phone number is 867-5309. So that is the answer to number 5. It is 867-5309 is the phone number. Alright, what is the inode number? Whoops, let me clear my screen here. Get back into my home directory. It says, what is the inode number of the uptime utility on the class system? Well, we know we can run the uptime command, But where is the uptime utility located? So I could use which uptime, I could use where is uptime, I could use locate uptime, and what we're going to see here is that the utility is in user bin. So user bin uptime, where is shows me user bin uptime, and locate shows me user bin uptime. Another command which is helpful, which I sometimes like to use, is find from the root directory the file named uptime, and then print that, and I send the output for any error messages to dev null because I don't want to see any error messages. And then you simply hit enter, and what that command will do is it will actually look at the entire file system from the root directory down into every directory into which I have permissions to looking for the uptime utility. So if there's something that you've created, or maybe you've got a pretty extensive directory file system structure in your home directory, sometimes you can use the find command when things aren't in your path statement or the system can't locate them for you. So it's user bin uptime. So if I type ls space lai on /user bin uptime, I can see that the inode number I'm looking for is 3259039. So that is the answer to number 6. Number 7. Who was the original author of the man utility? Well, if I want to know about the man utility, I could simply type man space man. And author section is always at the end. John W. Eaton was the original author of man. So the answer would be John W. Eaton for number 7. Number 8. The user TPB logged onto the class system, vader.aacc.edu, back on Thursday, September 19th. At what time did that session start? So again, remember the last command, which will show me everybody that's logged on. It keeps a record of everybody that's logged on until the log file is, I don't want to say truncated, until the log file is rotated, and it gives you a listing of everybody that's logged on. So if we're looking for TPB, I could simply do last and pipe it to TPB. Oh, I apologize. Last and pipe it to grep for TPB. At which point I'm going to get a listing of all of TPB sessions, and I can see that here is the September 19th session, and that session started at 9:42 a.m. So the answer to number 8 would be 9:42 a.m. Okay, there is a test user configured on the class system vader.aacc.edu as part of the course CSI135, Section A. What is the real login ID associated with that test account? It says use the Etsy password file for your search. So there's 2 ways you could have done this, possibly more, but 2 that we'll talk about. I could cat Etsy password, and I could grep on test, right? And here's the test account, and they are certainly in CSI235A25. And this is the course we're looking for, and here's the login ID right here. And remember, the password file, each entry in the password file has 7 fields. These fields are separated by colons, right? You see the colons here. And the first field is the login ID field, or the user ID field. The second field indicates that there's an Etsy shadow file on the system, and this is typically it'll show you the encrypted password, but when Etsy shadow is in use, you do not see the encrypted password here. The next field is the user ID field, or the UID field. The next field is the group ID field, followed by a comment field where you can put in maybe the user's real name, contact information, followed by the absolute path name to the user's home directory, so the directory that they are placed into when they log in, and then finally the 7th and final field is the default shell for that user. So I'm using bin bash. And again, we talked about the ID command as well. If I type ID by itself and I hit enter, you can see here's my UID, or my user ID, and then here's my group ID. So let's check. Let's cat the Etsy password file, and let's grep for CSI135B25, and sure enough, there's the 3rd field, which is my UID, and it matches the output from the ID command. So the correct answer, what is the test account for CSI235 Section A user is CSI135-400. That is the test account. So that's the correct answer for number 9. Number 10. There is a file located in the following directory, so I'm going to cd into this directory. And we're going to copy this here, and I'll paste it out here. And let's take a look at this file. Alright, it says this is a huge file, dude. Alright, and in fact, this is 26 million bytes, right? So 26 megabytes in size. So what we've got here is a very large file. And it says your task is to determine which compression utility, either bzip2 or gzip, saves you the most space when compressing the file with the name, and then it gives you the file name, and to provide the size of that compressed file in bytes. And it says, hint, the Linux utility CP will be required to complete this one. And here's why. So if I were to do the gzip command with the -v on this is a huge file, and I hit enter, you can see permissions denied. What about bzip2? -v on this is a huge file, permission denied. So this should be your hint that you need to copy this file, and I'm going to go ahead and put it in my home directory, right? So // and I will just put in here, we'll call it huge file. Alright, so now when I cd to my home directory, let's clear the screen, type ls-lai on huge file, and you can see it's the same file, and it's the exact same size, 266.54184, right? 26,654,184 bytes. So now let's give it a try now. If I do gzip-v on huge file and hit enter, you can see that 99.3% of the file has been replaced, and that happened. That was very, very quick, much quicker than bzip2. So if I were to type ls-lai on hugefile.gz, because remember the file has been gzipped, you can see the size is 187,725 bytes. So 99.3% compression ratio. Alright, so let's un-gzip this file. Let's see how fast that happens. Very quickly. And let's do ls-lai on huge file. Make sure we have the same file. Alright, there we go. So now we'll do bzip2 with a -v on huge file. And you'll notice one thing immediately, and that is that the bzip2 utility takes a substantially longer time to compress this file than did the gzip utility. In fact, this can take almost up to a minute. So while that is compressing, and that's the end of the quiz file, right? And we're going to find out the answer to number 10 here in a second. So I'm going to quit. I'm going to clear my screen, and let's see if there's a man page for bzip2. And there certainly is. And it says bzip2 compresses files using the Burroughs-Wheeler block sorting text compression algorithm and Huffman coding. Compression is generally considerably better than that achieved by more conventional LZ77 or LZ78 based compressors, and approaches the performance of the ppm family of statistical compressors. So there's some more information here that talks in general about bzip and how bzip works with different options. The decompress option, you can see there, -D, the force option, and I think we're done down here. All right. So this wrapped up. It saved 99.64% has been saved. So let's type ls huge file. Let's do ls-la here. Let's do ls-lai on huge file, and let's take a look. All right. In fact, you'll notice that bzip2 was able to compress this file down with almost a 100% savings when compared to gzip. So no question in this instance that bzip2 created a much smaller file than gzip did, and the size of the file is 95,720 bytes. That's your answer for number 10. All right, this has been the solution set video for quiz number 1, and I hope that everyone did well on the quiz, and I hope that this video has been instructional and informational and that you've gotten some value from it. All right, I will see everybody on Wednesday night. Enjoy the rest of your weekend.